Welcome to our journey into the fascinating world of car mechanics. Today, we delve into an exploration like no other, unveiling the hidden marvels that make your vehicle tick. Imagine a symphony, each instrument playing its part in perfect harmony. That's what happens under the hood of your car every time you turn the ignition. We'll be exploring the main components of a car's mechanical structure, including the engine, transmission, suspension, and braking system. Each of these parts, intricate in design and function, work in unison to transform raw power into motion. From the roar of the engine to the smooth change of gears, from the stability provided by the suspension to the decisive halt by the braking system, each component has a unique role in the grand performance that is driving. Fasten your seatbelts as we drive into the heart of a car's mechanics. At the heart of any car lies its engine, a marvel of mechanical engineering. Imagine a bustling city, humming with energy and activity. That's precisely what's happening inside your car's engine. It's a lively place where countless parts work together to keep your car moving. Let's start with the arrangement of cylinders. Typically, you'll find engines with 4, 6, or 8 cylinders. These cylinders are arranged in several configurations, inline, V, or flat, each with its own benefits. Inside these cylinders, a fascinating process takes place, the combustion process. The combustion process is like a carefully choreographed dance. First, a mixture of air and fuel enters the cylinder. Then, a piston compresses this mixture, making it highly explosive. A spark plug ignites the compressed mixture, causing a small but powerful explosion. This explosion pushes the piston down, creating a force that turns the crankshaft. Now, let's introduce you to a few of the key players in this process. The pistons, these are the powerhouses, moving up and down inside the cylinders. The crankshaft, this is the maestro, converting the up and down motion of the pistons into a rotational motion that drives the wheels. Then we have the camshafts, operating the engine's valves to let in air and fuel and expel exhaust gases. It's crucial to note that each engine component has a vital role to play. Imagine an orchestra where every instrument contributes to the final symphony. That's how the engine works. Every part, from the smallest bolt to the largest piston, is essential to keep the engine running smoothly and efficiently. In essence, a car's engine is a complex yet captivating piece of machinery. It's a testament to human ingenuity, showcasing how we've harnessed the power of combustion to keep our world on the move. That's how the engine generates power, but how is it controlled? Let's shift gears and find out. The transmission system is the bridge between the engine and the wheels. It's the unsung hero that makes sure your car's engine power gets to the right place at the right time. So let's dive in and explore how this mechanical marvel works. There are 3 main types of transmissions: manual, automatic, and continuously variable transmission, or CVT for short. Manual transmissions, often called stick shifts, give the driver full control over gear changes, while automatic transmissions handle this task all by themselves. CVTs, on the other hand, are a bit different. They don't have set gears, but rather use a system of pulleys to create an infinite range of ratios. Now let's talk about the gearing mechanism. Gears play a crucial role in every transmission type. They're like the translators of the car world, converting engine power into something the wheels can use. Lower gears provide more power but less speed, while higher gears give less power but more speed. This is why you start in first gear and shift up as you accelerate. But wait, how does the car disengage from the engine during a gear change? That's where the clutch in manual transmissions and the torque converter in automatic ones come into play. The clutch is like a switch, connecting and disconnecting the engine from the transmission as you change gears. The torque converter, on the other hand, is a fluid coupling that allows the car to stop in gear without stalling the engine. So, in essence, the transmission system is a complex dance of gears and mechanisms, all working in harmony to control the power generated by the engine. It ensures that the right amount of power gets to your wheels, whether you're pulling away from a stop sign, cruising on the highway, or climbing a steep hill. So that's how a car changes gears. But how does it handle bumps and turns? Let's steer towards the answer. Suspension and steering systems ensure a smooth and stable ride. Let's delve deeper into these vital components that keep our wheels firmly planted on the tarmac. The suspension system is a marvel of engineering, designed to provide a comfortable ride by absorbing the bumps and dips we encounter on the road. Key components include the shock absorbers, springs, and control arms. Shock absorbers do exactly what their name suggests. They absorb the shock from the road, reducing the impact on the car and its passengers. Springs, on the other hand, compress and expand to absorb the force of the road, while control arms link the steering and suspension system, allowing the two to work in harmony. Now, let's turn our attention to the steering system. This is where the magic happens, where your inputs at the steering wheel are transformed into movement. The steering rack and pinion play a crucial role in this process. As you turn the wheel, the steering column rotates the pinion gear, which moves the rack, ultimately turning the wheels. It's a direct, efficient system that gives you control over your vehicle's direction. But here's an interesting fact. Not all suspension systems are created equal. There are two main types: independent and dependent. In an independent suspension system, each wheel can move independently of the others. This means if one wheel hits a bump, the others aren't affected, providing a smoother ride. Dependent suspension, however, links the wheels together, so if one wheel moves, the others do too. While this might sound less comfortable, it's actually preferred in heavy-duty vehicles for its strength and durability. The combination of suspension and steering systems plays a pivotal role in your car's handling. They work together to ensure your vehicle responds accurately to your inputs and the road's contours, providing a smooth, stable ride. The right balance between these systems is crucial for optimal performance, comfort, and safety. Now that we've got a handle on steering and suspension, let's break it down. A car's braking system is crucial for safety, but what makes it so critical? Well, it's all about the components and how they work together to halt a moving vehicle. Let's dive into the details. Firstly, the brake calipers. These are essentially clamps that squeeze the brake pads against the brake discs to create friction. The brake discs, also known as rotors, are attached to the wheel, and when the brake pads press against them, they slow down, bringing the vehicle to a stop. Next, we have the brake pads. These are made of a high-friction material that, when pressed against the brake discs, helps slow the vehicle. Brake pads are designed to wear down over time, which is why routine maintenance is so important. Now let's talk about how these components work together in a hydraulic brake system. When you press the brake pedal, it pushes a rod into a cylinder filled with brake fluid. This pressure is then transferred through brake lines to the brake calipers, causing them to clamp down on the brake discs. This entire process allows your vehicle to slow down or stop. But what happens when you need to brake suddenly on a slippery road? That's where the anti-lock braking system, or ABS, comes in. ABS prevents the wheels from locking up or skidding during sudden braking. It does this by rapidly pulsating the brakes, allowing you to maintain steering control while stopping the vehicle. This feature is especially important in wet or icy conditions, where skidding is a serious risk. In essence, the braking system is a marvel of engineering, combining a number of critical components to ensure your vehicle can stop safely and effectively. From the brake calipers and discs to the brake pads and hydraulic system, each element plays a key role in vehicle safety. Remember, a reliable braking system is a key to safe driving. So, the next time you're behind the wheel, take a moment to appreciate the intricate mechanics that help keep you safe on the road. We've navigated through the complex mechanics of a car. We've taken a deep dive into the engine, the powerhouse of the vehicle, where we saw how cylinders, pistons, and camshafts work in harmony to bring your car to life. We then shifted gears to explore the transmission system, understanding how it controls the power generated by the engine. We cruised through the suspension and steering system, revealing how they contribute to a smooth and stable ride. We examined different suspension types and their impact on vehicle handling. Lastly, we applied the brakes to analyze the braking system, highlighting the critical role it plays in vehicle safety. We hope this exploration of a car's mechanical structure has sparked your curiosity. There's so much more to learn and discover. So, keep asking questions, keep exploring. Thank you for joining us on this journey. Remember to share, subscribe, and stay tuned for more automotive explorations.